Okay, so now we have another problem which is based on logistics regression and odds ratio. Okay, so we know that we use the logistics regression, okay, whenever we have a binary response. Okay, whenever we have y something either 0 or 1. Okay, so 0 means fail and 1 means success. Okay, so whenever we have this situation, okay, so we use the logistics regression. Okay, so we have a question, okay, and it says that a logistics regression model is fitted to study whether a patient recovers. Okay, so recovery means success, okay, when y is equal to 1 based on dosage x. Okay, so we have two things over here, y, which is a response, okay, so it is 0 or 1. This is do not recover, and 1 is recover. Okay, and x is the dosage. Okay, and we are given that the relationship, okay, it is given as log of p minus divided by 1 minus p, okay, is equal to minus 2 plus 0.6 into x. This is the relationship. Okay, so this is the regression equation. Okay, this is the relationship between the dosage x and the success. Okay, y is equal to 1. Okay, so p is when y is equal to 1. So the very first thing that we need to that we are asked is to define the odds. Okay, just define odds. Okay, so log of odds is equal to minus 2 plus 0.6 into x. Okay, so for any specific value of x, we can find the probability of recovery. Okay, we can find the odds ratio. Okay, we can interpret at any level. Okay, so by definition, odds is the what we say, the chance of success relative to failure. Okay, so odd is success divided by failure chances. Okay, success chances divided by failure chances. Okay, we know that success chances is equal to p. Okay, this is the probability that y is equal to 1. Okay, this is p. Okay, and the failure f is the probability that y is equal to 0. Okay, let me write it over here. Probability that y is equal to 0 such that x, okay, for any specific value of x. Okay, and probability that y is equal to sorry, this is 1. Okay, y is equal to 0 such that x. Okay, probability that output is 0. Okay, the patient do not recover such that any dosage value. Okay, so it is a relative thing. Okay, so defining odds, so it will be equal to p divided by 1 minus p. Okay, the probability of success divided by probability of failure. So probability of failure is equal to 1 minus probability of success. Okay, because the probability of failure plus probability of success is equal to 1. Okay, so probability of failure is equal to 1 minus probability of success, while probability of success is equal to p. Okay, so failure is equal to 1 minus p, so p divided by 1 minus p is equal to odds. This is odds. Okay, so the first thing, odds is defined. Now we move to the next thing, which says that calculate odds at x is equal to 3. Okay, so for a specific dosage value x is equal to 3, we need to calculate odds. Okay, so let's find out. So from the logistics regression equation, we have log of odds or p over 1 minus p is equal to minus 2 plus 0.6 into x. Now x is equal to 3. This is the dosage level. Okay, so at x is equal to 3 we need to define the odds. Okay, so we have log over here. Okay, log of odds is equal to minus 2 plus 0.6 into x. Okay, now log of odds is equal to minus 2 plus 0.6 into 3. Okay, so I have put x is equal to 3 over here, so we will get 6 into 3 is 18. Okay, so the it will be equal to about 1.8. So minus 2 plus 1.8, it will be equal to minus 0.2. Okay, this will give us 1.8, and minus 2, it will be equal to minus 0.2. Okay, this is equal to log of odds. Okay, now we need to define only odds. Okay, so what we do is we are going to shift this log from this to this direction. So odds is equal to, okay, we know that log of e is equal to 1. Okay, so using this relationship, okay, we can shift this e to this direction, okay, and this to the other direction. Okay, so we will get odds is equal to e raised to the power minus 0.2. Okay, so odds is equal to e raised to the power minus 0.2. So when we calculate e raised to the power minus 0.2, we get 0.82 approximately. Okay, so this is the odds value at x is equal to 3. So what does this actually mean? Okay, it means that there are more chances of success than failure. 80%, almost 82% more chances of success than failure, as there are 82% more chances that the patient will recover as dosage x is equal to 3 than the failure. Okay, so the patient recovery chances are 82% more than the failure at x is equal to 3. This is the definition of odds. This is the interpretation of odds. Okay, now we have calculated the odds. Okay, the third part we are going to do is to find the probability of success, p, probability that the patient will recover. Okay, so we know that the probability to recover is equal to odds divided by 1 plus odds. Okay, this is the basic equation that you need to memorize. Okay, probability of success is equal to odds divided by 1 plus odds. So odds value is 0.82. Okay, this is for at x is equal to 3. Okay, so for any x you can find the probability of success. Okay, odds shows the relative frequency. Okay, there are 82% more chances of recovery than failure. Okay, but this doesn't show the recovery chances, exact recovery chances, not related to failure. Okay, so what we are going to find is the recovery chances not related to failure. Okay, not relative to any failure, but only solid probability of the success, or what we can say the recovery of the patients. Okay, so it is equal to odds divided by 1 plus odds. So at x is equal to 3, odds is equal to 0.82. So 0.82 divided by 1 plus 0.82. Okay, so it is equal to 0.82 divided by 1.82. Okay, so dividing this, okay, we will get about 0.45. Okay, or 45% chances. Okay, So the solid chances of recovery at x is equal to 3 are 45%. If we keep the dosage level is equal to 3, okay, then the recovery chances are 45%. Okay, now we have another part which is D. Okay, it says to interpret beta 1. Okay, so interpret beta 1. Okay, now we know that the beta 1, okay, is the slope actually, okay, and it shows that if we increase the dosage level, if we increase the dosage level by 1, how many chances of recovery, it multiplies. Okay, so how much the recovery chances are improved, how much recovery chances of patient are improved. Okay, so we know that the coefficient of beta 1, it has a value of 0.6 as per the equation. Okay, so what we do is we take the exponential exponent of e raised to power 0.6, the beta 1 value. Okay, so the value it gives us is 1.82. okay, so it means that if we increase the dosage by 1 unit, so the odds of recovery are multiplied by 1.82. okay, so it increases its chances by 82%. This is the basic interpretation of beta 1. Okay, so what concept that we used is, we use the concept of logistic function or log function, okay, which was this. Okay, this is the logistics function. Okay, log of the odds is equal to minus 2 plus 0.6 into x. Okay, so this is regression and this is the logistics part of it. Okay, log part of it. Okay, so what we studied next is the odds and odds ratio. Okay, so we calculated odds. Okay, we calculated odds ratio, which is equal to e raised to power 0.6. okay, this is the odds ratio, this is odds ratio. Okay, so these are the basic concepts that we studied over here. Okay, what you need to basically understand or know is to have the logistics regression equation, okay, and relate it to the x. Okay, you need to understand the odds, okay, and how to calculate it. Okay, so taking an exponent e, okay, it will remove the log, okay, and you will give you only odds. Okay, and then the probability of success. Okay, so odds is the relative probability of success. Okay, probability of success relative to failure. Okay, so it relates the probability of success with the probability of failure. Okay, so if it has negative, it means that the probability of the chances of success is less than the probability of the failure. Okay, and if it is positive, okay, it means that the chances of what we say, the success are greater than the probability of the or chances of the failure. Okay, so it is a relative term, odds. Okay, then we have a solid probability p. Okay, so it is equal to odds divided by 1 plus odds. So at any related x value, for any x value, we can have odds, and then we can have the probability of success solidly. Okay. If we compare both these two, okay, it says 82% and it says 45%. Okay, so this is 82% success more than failure, and this is only the percentage of success. Okay, and then obviously we can use the odd ratio to interpret beta 1. Okay, and as we say, beta 1 is the increase in the x. Okay, and we see how much the output variable changes, how much jump it sees in per unit change in the dosage level or x. Okay, and this is the done by odds ratio, e raised to power beta 1. Okay, this is the odd ratio. Okay, e raised to power beta 1 is equal to odds ratio. So odds ratio gives us the interpretation of beta 1. Okay, so this is the basic, very basic things of logistics regression. Okay, you need to understand this one problem is must on this concept. Okay, I hope you have got all the information correctly, and you can now interpret the question and can answer it. Okay, if you have any problem, please give me specific things like how can I do this, how can I do this. Okay, thank you.